Good day. We are going to start chapter 4 today, and that is about exponential and logarithmic functions. If you have your notes handy, this would be a good time to get them out and fill this in as we go through this. So our goals are to recognize and evaluate exponential functions with a base of a. We're going to graph those exponential functions and then write equations of exponential functions. Okay, now we have only studied algebraic functions to this point. Those include polynomial and rational functions. But in this chapter, we're going to look at non-algebraic functions, both exponential and logarithmic. They're quite fun, actually. They're called transcendental functions. Don't ask me why, not sure. But here is the general form of an exponential function. F of x equals a to the x, where a is greater than 0 and a is not equal to 1, and x is any real number. So now what we're going to do is we're going to use our calculator to evaluate each function at the indicated value of x. So we have f of x equals 2.3 to the x. X is equal to 5.6. So what we're going to do then is we're going to go ahead and substitute 5.6 into x. 2.3 to the 5.6 is equal to about, type it in on your calculator, if we go to the nearest thousandths place, tenths, hundredths, thousandths, I think it's 106.090. All right, letter B is f of negative 2 with negative 2 times 20 to the negative 2 power. All right, now, the x in front is called the coefficient, okay? The base is still 20. The exponent is x. So our exponent now is negative 2 as well as our coefficient. So negative 2 times 20 to the negative 2 is about, again, we're going to use approximately. I got negative 0.005. And then the last one, simply f of 2, so pi squared is about 9.870. So those are just plugging in numbers for either the variable or either the exponent. Well, in this case, all three of them were the exponents, and then we also had a coefficient of x on b as well. So now, the parent function of an exponential function, y equals a to the x, where a is greater than 1, is going to look something like this. So if you plug in 0, a to the 0 is 1. If you plug in 1 for x, in this case, this one is 3 to the 1. See that right there? So 3 to the 1 is 3, so our base must be 3 in this case. How do I know that? Because 3 to the 1 is 3. If I go 3 to the 1/2 would be, let's see, that'd be 3 to the 1/2 is the square root of 3, about 1.7. That looks about right, doesn't it? Okay, so the domain then of this, of all exponential functions, is negative infinity to infinity. There is no domain restriction. Now, the range, however, as you can tell, we have a horizontal asymptote right here, and that's y equals 0. So our range then is 0 to infinity on this graph, this particular graph. The y-intercept is 0, 1, and the vertical asymptote does not exist. We do not have a vertical asymptote on exponential functions. Not on exponential. We have horizontal asymptotes. So, transformations, we're going to look at how we can move them around, and it is very similar to what we just did, and I believe in chapter 2. So again, if the transformation is inside the function, as in this right here, g of x equals f of x plus c, the graph is going to move horizontally. It's going to move left if it's addition, if it's going to move right if it's subtraction. And then if we put the negative of the of the variable, it's going to reflect over the y-axis. Now that's a little different. We're used to having it reflect over the x-axis. Is that right? Yes. If it's outside the function, we're going to move it vertically. And if we're going to shift it over the x-axis, we're going to reflect it. We're going to negate the function. Now before we move on, I'm going to make sure that's the case. Let's see, 3 to the x. Give me one moment here. So if we negate the x, yes, indeed, we're going to reflect it on the y-axis, and if we negate the whole function, we're going to reflect it on the x-axis. So we're going to describe each transformation here, and we're going to do what is happening. We're going to fill out this form right here. So the transformation, first of all, 4 to the x minus 1, we're moving it down 1, correct? Our domain is always negative infinity to infinity. In this case, since we moved it down 1, our range is 1 to infinity. Looks like our y-intercept, if I put 0 in there, 4 to the 0 is 1, 1 minus 1 is 0. So it's 0, 0. Remember, there's no vertical asymptote. And our new horizontal asymptote is y equal negative 1. Okay, example 2, same idea here. Since it's in the exponent, or in the, see how it's outside the function? Now the negative 2 is inside the function, so that is going to move it right, oops, apologize. That is going to move it right 2. What just happened here? There we go. Right 2. The domain is still negative infinity to infinity. The range you can see is still 0 to infinity. Now the y-intercept has to be found by putting 0 in to x. So that's going to be 3 to the 0 minus 2, which is 3 to the negative 2, which we flip to make positive. So it's 1/9. So 0, 1/9 is our y-intercept. There is no vertical asymptote, and our horizontal asymptote is still y equals 0, because we just moved the graph right 2, 1, 2, because normally it's going to be here, but we moved it 1, 2 to the right because of this right there, that minus 2 in the numerator. Okay, now this is where it's going to get a little bit different, a little more difficult here. So we're supposed to find the equation of the graph that is has points given, okay? So in this case, we have 225, and it looks like 0, 1. How are we going to find the equation between those two? Well, one way to do this is to take this and divide it by this again. Now you look at this and go, wait a minute, what's he talking about? Well, you have 2 points. This point is on the right, this point is on the left. You do not know what our A is, because we know our X's and our Y's. And this is 0, 1, so we know that X and Y. So we can just plug this in. We know that f of x is 25. and that equals a to the x, 2 to the x, over, well, that's 1, and this is a to the 0. Correct? Oh boy. This might require logarithms. Oh, what am I doing here? We don't know a. Come on, guys, help me out. We don't know a. It should be a to the a squared. There we go. A to the 2, because 2 is x. There we go. So a squared is equal to 25, because a to the 0 is 1. So we got it. Now we just take the square root, and a is 5. So our equation then is y, well, let's use f of x. F of x equals 5 to the x, because 5 squared is 25. 5 to the 0 is 1. 5 to the 1 is 5. Okay? Now, what this is doing is it's getting you ready for a little more complex problems in the future. Okay, that's why I'm showing you this method. Again, f of x equals a to the x over f of x equals a to the x over a to the x. This is the right point. This is the leftmost point. So again, it's 1/8, and our a is 3. And here it is, let's see, 0, 1 is our other point. So 1, a to the 0, but this is nice because that's 1 again. So 1/8 equals a cubed. Well, what do we cube to get a? 2, right? So a then is going to be 1/2. So this graph would be f of x equals 1/2 to the x. So it's decreasing. And that is our 4.1 lesson. I believe your assignment is on WebAssign.